Hi, so you welcome back after the break because we both have the COVID, and today we will continue our journey to the decentralized world and especially the decentralized identity. So last time we had a quick chat what we could have for the identity, what the soulbound token is. We talk a bit about the NFTs, and I already touched the topic of the decentralized IDs. So today we will have a chat about what decentralized ID actually is, and especially how to do the massive scale decentralized IDs, because majority it's hundreds and hundreds of the DAD methods, and decentralized ID usually how it look like. You have the DAD, after that you have this column, the DAD method, yet another column, and some magic hash. So then this magic string actually it's your DAD. So and this DAD allows you to actually in some way to resolve your DAD string to the document that will contain your public keys and allow you to identify yourself. So it's the general idea that we could exchange our magic string, the DAD itself, to the DAD document. And a bit of the terminology, that process of resolving the DAD string to the DAD document, usually called the resolution process. The process of connecting the DAD string with the DAD document, especially on chain, called the anchoring. So you create the anchor between the DAD and DAD document on the chain, and that's it. But what's actually the DAD method mean? So DAD method is super simple. So it's the way or the protocol that describe you how you could create your DADs, how you could associate your DAD with the DAD document, how you could update this DAD document, and how you could delete it, and so on. So it's in general just standard CRUD operations. And it's hundreds of these methods. Some of these methods are connected to the blockchain. Some of these methods is off-chain methods. Some of them actually could be the hybrid, that they could be on-chain but offer you some off-chain. And in the most cases, we are quite interested in on-chain methods, because with on-chain methods, we have a safe possibility to verify them, and most important, to change the DAD documents on fly. But with the on-chain methods, for example, most popular one is the DAD for Ethereum, or DAD Sol for the Solana, or DAD Polygon for the Polygon chains. So practically every new chain really invests a lot and give you the grants to implement the DAD method on top of the blockchain or subchain, and you could really find a lot of grants for the new subchains that ready to pay you if you will implement the DAD protocol on top of it. But with these chains methods, we have one simple problem, that to make the anchoring happen, to store this DAD document in a chain, usually you need to pay. So if you need to generate thousands and hundreds of thousands of the DADs, actually it came with the cost. First of all, the storage in a contract usually costs money, so people make the workaround, and majority of the DAD methods, if storage is quite costly on chain, they store the documents somewhere, for example, in IPFS or Ceramic or whatever, and store in chain only the hash of this or address of this document, and so on. But the problem with on-chain methods, even if it's on Polygon or some cheap blockchain, that you need to pay for every DAD that you produce, and for some protocols you need to generate them for every transaction or for every pair of folks that do the transaction. That's why actually the some protocol of the second level appear, and we will talk actually about such a protocol. It's called the sidetree. So what kind of problem sidetree solve? It's exactly we get the DID method that is on chain, on top of Ethereum chain, and but in the same time it's in a cost-saving manner, because you have the protocol not bound you to the blockchain. It was not right. So the protocol describe how you could create the DIDs, what kind of data you could have, and how they interact with the user storage, the blockchain, and so on. So this protocol is quite flexible. You could have a lot of implementations. So sidetree have a couple of concepts. First of all, yeah, they have the interface that defines how you interact with the ledger. Usually with the ledger, it's two guys that will work with the ledger. It's observer that will read the batch operations from the ledger, and the writer that will write the batch files to the IPFS, and then will create the endcurrent files, and endcurrent files will be actually connected to the blockchain. But what we will get with the sidetree is the possibility to create the millions and millions of the DIDs, but still in a manner that you pay not for DID, you pay for the large batches, and in a batch you could have the thousands of the DIDs. And how it's work? It's quite interesting, because on practice you're not writing the DID document itself. You have the CRDT, so that's some small JSON-like data structure that it's mergeable without the conflicts. And you describe not the DID document, you describe the DID document and in terms of the operations that you could apply and get your document. So for example, we want to create the DID document, so we have the create operation or replace operation that define our public keys. After that, maybe we want to add a couple of other public keys, for example, BBS plus signatures or whatever. So you have create operation and two updates operations. So you create these three operations. These three operations will go to the signed batch file, and this batch file will be stored in IPFS and local cache. And after that, these batch files and their signed signatures will be included to the endcurrent file, and endcurrent file will go to the IPFS, and hash of this endcurrent file will go to the contract in blockchain, and other people could fetch this endcurrent file. After that, fetch the batch operation files. After that, fetch the operations, and every time when you will came to some other node and provide them the DID hash, they will take a look to the local operations cache, find all operations that related to your DID, and just replay them like in the movie or like in a Kafka events. And after that, then they will calculate on fly your DID method. And it sounds complex, but this allows us to make the quite fast throughput, fast resolution, limitate a bit the propagation time, so your DID will not be resolvable out of the box. It will be some period of time where you put the operations to the blockchain, and other nodes should read these operations from the blockchain. So the propagation time could be large, and it's one of the downsides of the sidetree protocol. You define actually the periods where you write the batches. Yeah, and these periods could be minutes, could be hours, could be days, and it's completely up to you. It's depend on your budget. So the main benefit of the sidetree that you could calculate how much money you spend, because you control the periods of the writes. Yeah, and if you want to have the fast resolution, you should have the shorter batch writing periods. If you okay that this DID will appear somewhere in the future, then you could have the longer batch periods, and sidetree allows you to create a long form of DIDs, so it will add to the DID some query parameters that allow you to resolve still the DID without the anchoring it to the blockchain. It's yet another interesting topic that we will talk maybe later, but sidetree allows us to create massive scale issuance of the DID documents with the cost of one single Ethereum transaction per thousands of the DIDs, and it's worked perfectly fine when we produce a lot of DIDs in some period of time. If we produce the small amount of DIDs from time to time, it's the worst scenario, because we're not writing the empty batches, but we write the batches in some period of time that actually have the operations. So if you resolve, if you issue one DID per 2 hours, and you just have the writing period of 1 hour, it means that you practically have the same cost, because it's practically the same as you will anchor the single DID to the chain. But it's have huge potential. So as I mentioned, the sidetree is just a protocol and reference implementation. If you want to see the applications of it, you could take a look to the DITION. So it's most popular one, and Microsoft invests a lot of efforts and a lot of forces to promote the DITION, because it was made practically by Microsoft guys, and it's built on top of Bitcoin. The DIT element is what we use in Affinity. It's quite interesting DIT method that actually utilizes the Ethereum as a ledger, and IPFS as a addressable storage. So the CAS, it's actually the IPFS. I built a couple of DID methods on top of the sidetree when I was in my sick leave based on Solna and Ceramic. So you could build your own if you really want. And yep, so Proton, it's yet another DID method that actually was made by the same team as a DIT element. But it's used some Amazon blockchain and so on, and the S3 as storage. So as you see, it's a lot of different varieties, some of them completely decentralized, some of them a bit centralized, and so on. It's up to you, but if you want to have the massive scalability, you could use something like the sidetree for the DID documents. So that's all. I will leave some links in video description to the protocol itself, to the some most famous DID methods. Yeah, and let's discover the identity and decentralized world together. Write the comments, subscribe to our channel, provide your feedback. I will be happy to hear what you want to know more about the topic and what you're doing in this space. And yeah, so have a nice day and see you. Please put likes